Okay, these are the 5-3 notes for graphing radical functions. So it's going to start out by asking us to kind of define in our own words what is a radical function. How do we recognize that? So I'm just going to go ahead and tell you in my own words. Let's get my pencil working here. Here we go. A radical function has an x or a variable under the radical symbol. Okay? So what might that look like? That might look like y equals the square root of x. Okay, so that's an example of that. So the core concept we're working on is we're going to be dealing with those parent functions, first off, for the square root and the cube root. So there are other things that might come up, but we are just dealing with the square root and the cube root parent functions for now. Okay? So there's not a graph on here, so I'm going to start by drawing myself a little graph. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7. Okay, put some hash marks on there. And what it's asking me is, what is the parent function for the family of the square root function? So we've got the function f of x is the square root of x. Well, I like to do that by, let's start out, I love my t-charts. I find like they're very clean and easy to follow. So let me go through a few values. When x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. And I'm not going to try 2 or 3 because they don't come out evenly. They would give me a decimal or a fraction, and it would be harder to graph. So I'm just going to go ahead and skip right ahead to 4. The square root of 4 is 2. And the square root of 9 is 3. And those are standard entries for a graph like this. Those are the easiest points to plot. So when I do that, let's go ahead and start with my 0, 0, which will be there at the origin. And then for point 1, 1, I'm going to go to the right 1 and up 1. My next point is 4, 2, so I'll go to the right 4, and I'll go up 2. And then my final point on this graph is 9, 3, so I'll go right 9 and up 3. It should be somewhere like that. And then I'm going to connect them with a nice, smooth, continuous curve. And that goes on forever and ever, so I'm going to draw my arrow there on the end. Look good? And the domain and range, and it says that the domain, so my x values are all greater than 0. Well, when I write that in interval notation, that just tells me that my leftmost boundary is 0, and my rightmost boundary continues all the way to infinity. And to write the range in interval notation, I'm doing the same thing. So it's telling me that y is always going to be greater than or equal to 0. So written in interval notation, that means the lowest point of my graph is 0, but it continues through to infinity. Okay, so that looked easy. That looked nice and clean. Let's try this now with the cube root function. So this is going to, let's see, 5, 6, 7, 8. I'm going to give it 8 points. 5, 6, 7, 8. I'm going to give that, and let's do like maybe 4 up and down. All right. So the parent function for the family of cube root function, f of x equals the cube root of x. So again, I'm going to start with that chart, with my t-chart there, with my x values and my y values. Remember, y is that function, so we know that y is going to be the same thing as the cube root of x. Okay, so where x is 0, y is 0. Okay, so when x is 1, the cube root of 1 is 1. And something that happened over on our square root function is we don't have any negative values because we can't take a square root of a negative number and still end up with a real number. And, you know, we want to stick with real numbers. We don't want to have to deal with the complex numbers and i's and all of that. So that we didn't include any negatives over for the square roots, but in the cube roots, we can do that. So we can do -1. So when x is -1, the cube root of -1 is -1. And we know that because -1 times -1 times -1 is -1. Okay, and then again, we're going to skip over to a nice pretty number, and let's say 8. So the cube root of 8 is 2. But we can also do that -8, which gives us a -2, because -2 times -2 times -2 yields -8. Okay, so let's graph that. So my first point is at 0, 0, right there at the origin, super easy. The first one on my list is 1, 1, so I'm going to go in the positive direction 1 and then up 1. My next is -1, -1. And then I've got 8, 2. And -8, -2. Okay, well this looks like there's these dots everywhere. It's just kind of wonky if you don't know what it's going to look like. So let's kind of connect these in a nice continuous line and see that it kind of looks like a smashed or a skinny S or a snake of some sort. And that's the parent graph of that cube root function. So you're going to always kind of have that shape when you're dealing with the cubed roots. Okay? So far, so good. Let's look at that domain and range. It says all real numbers. So again, since we're dealing with interval notation, I just want to go ahead and write that out again. So my domain, the farthest left, my left boundary is going to be -infinity. My right boundary is +infinity. And my range, well, it's the same. This is going to continue to drift downward the farther out it goes, so -infinity. And it'll never end this way. It goes to +infinity. So when we're looking, what's next on here for us is this table. And it kind of goes through a few things that help us remember some ways to manipulate or transform our graphs. And we used them before when we dealt with other parent graphs, like when we worked with quadratics or absolute value. I'm sure you moved things left and right and up and down, and you shrank them and stretched them and did all those types of things that you might do. Well, it's going to be the same with these radical functions. So a horizontal translation. So we know that translation just means that it's going to shift. And horizontal is in the direction of left, right, okay? So it's going to be underneath the radical sign with the variable. So when it is in there with it, that -2, we're looking at that. That's with the x. That's what doesn't belong. And we know that it's going to go the opposite of what we'd intend when it's underneath there, or what we'd expect. So that's where we get, instead of negative being going to the left, it's actually going to go to the right. So 2 units to the right. And here we go with this one. We've got a +3. So we know that it's going to be moving 3 units. And is it going to the left or is it going to the right? Well, we would expect a positive to go to the right, but it actually goes to the left when it's inside that grouping. Now the vertical translation. What's going to be different with the vertical translation is that it's going to be outside of it. So it's not going to be inside there with the x. It's going to be tacked onto the end there. So here we've got a +7. Well, outside of it, +7, we know that the 7, it's going to manipulate it 7 units, and the plus makes it go up. -1, it's being manipulated 1 unit, and then it's going to go down because it's a negative. So when it's outside, it's going to go exactly the way you'd expect. When it's inside with the x, it's going to go the opposite direction. And reflections. This first reflection here, you don't need to worry about. That's not part of the standards we're covering right now. So you can just mark that out. It doesn't pertain to anything that we will be dealing with in this class right now. But the other one does. The other part is we're going over the x-axis, okay? So we're going to be dealing with the x-axis here. So when you see a negative in front of it, so here we've got our square root of x, right? There's our radical. But we've got this negative sign out front. That negative sign out front tells us that it has flipped over the x-axis. Okay? It's flipped over the x-axis. With a horizontal stretch or shrink, again, we're not going to be dealing with that. That's not part of the it's not part of the standards that we're dealing with right now. So go ahead, and you don't even need to pay any attention to that particular block. But we will pick it up on the very next one where it's not horizontal, but it's vertical. So we're looking at the vertical stretch or shrink. And that is this number A that's out front of what we're dealing with, okay? So looking at it, that tells us that it's going to stretch away from the x-axis, or it's going to shrink down toward the x-axis. So it's going to get taller or it's going to get flatter. Well, 4 out front means that it is going to stretch by a factor of 4. And if you recall, did we deal with that yet? No. So this out front is a factor of 4. That is how much it's going to stretch by. So when we have this fraction, the 1/5, that's telling us it's going to shrink. So when A, or the number out in front of there, is greater than 1, that means it stretches, okay? So when it's a whole number, so it's not anything less than 1, it's not a fraction, it is just a whole number, that means it's a stretch. But now, if A is between 0 and 1, okay, so that means it's greater than, hold on, where's my undo button? So when A is between 0 and 1, that means it's a fraction. It's bigger than 0, but it's smaller than 1. It's a fraction. That means it's going to shrink. Now, if you notice, nowhere on here is it less than 1, because that would just mean it's a negative number. And if it's a negative number, we're not dealing with a stretch or shrink. Negatives show us that reflection where it flips over. Okay, so that's not. So we just deal with just the number, not the sign, as far as for looking at these transformations. So let's work through a few examples together. For these exercises, we're going to graph it, and we're going to identify the range and domain in interval notation. So starting, the first thing I'm going to do is I'm going to look and I'm going to try and recognize what is the parent graph. Well, this is the cubed root. Okay, so I know it's going to be that S kind of shape. And I'm going to start by getting myself some values to deal with. So I've got my X and my Y. And I know that my Y is going to be the cube root of X, wherever that is. So I'm going to use those standard numbers that we already kind of talked about. These are standard for cube root. They're the first ones that come out nice and pretty. But I can't just go ahead and graph it on there because I noticed that there is this +1 that is attached. So I need to determine, what do I do with that? Because I know that that changes like where I'm going to start this. The whole graph shifts. Okay, so it's not inside the radical with my X. So I know as it's on the end there, on the outside, that it's moving up or down. So a +1 moves me up 1. It shifts my whole graph up 1. So that's my new 0, 0. So that point is the point I just plotted. So from there, I'm going to go ahead and graph 1, 1, -1, -1. Going back, treating that shifted one as my 0, 0 again, I'm going to go -8, -2. So that's probably right about here. And +8, +2, going to be right about here. Okay, and then I'm going to connect that with as smooth and continuous of a curve as I can with my very limited skills. And there we go. It should look something like that. So now the only thing I have left to do is determine the domain and range. That's what it's asking for. Well, I'm looking at this and there's arrows on both ends, so I know it's going to continue going to the left forever. It has no left boundary other than negative infinity. And my right boundary is infinity. And the same thing with up and down. The bottom is going to drift down towards negative infinity, and the top will drift towards positive infinity. Okay, so now this one looks a little bit different because so far all of these notes we've dealt with something that had that radical symbol in it, and this doesn't. So I could get a little confused, but I'm not going to, because I'm going to recognize that anything to the 1/2 power is the same thing as squared. So I'm just going to, for the sake of me being able to do this in a way that's more comfortable for me, because it's what I just dealt with, I'm just going to rewrite it. And this means the exact same thing. These are equivalent statements. So now looking at it, my parent graph I see is going to be the squared. I'm sorry, that's wrong, square root. So I'm going to use those points that we've already talked about, my 0, 0, my 1, 1, my 4, 2, and my 9, 3. Because I know that, there we go. So that just tells me that, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Now, doing that, I'm looking at it and I'm thinking, well, is it ready to graph right now? And I don't think it is, because I have a couple of different things that have to happen to it. So first, I notice that I have this number out front, this 2, and this 2 indicates a stretch because it's a whole number, it's not a fraction, and that's going to affect my y values. So I'm going to multiply each of my y values by 2, and that's going to give me that stretch number. Okay. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So my new coordinates, I can get rid of those if I want to, if that's going to help me narrow down what I'm looking at. Okay, so now am I ready? Am I ready now to go ahead and start graphing? Not quite yet, because I have to move up, down, and left and right, right? So I've already dealt with my stretch. So this is my stretch. That's done. But what does this minus 5 mean? Well, it's inside the grouping. So I know I'm going to go left and right, opposite of what I would anticipate normally. So I know that I am going to go to the right 5 units. And finally, out here on the end, all by itself, I know I'm going to have to start down 4 units. The entire graph shifts that. So let's start that. I'm going to, instead of starting at 0, 0, I'm going to start right 5 and down 4, which puts me right here. That's my new origin, so to speak. That's my new 0, 0. So that's what I just graphed right here. From there, I'm going to go to the right 1 and up 2. So I know it's off the graph, but we're just going to kind of eyeball it here, right there. And then over 4 to the right and up 4. So it's going to put me right about there. And over 9. Wow, that's going to be like, and up 6. That's probably going to be like way over here somewhere. And again, I want to, there are no negatives on that, so I'm going to start at this 0, 0. I'm not going to put an arrow on, and I'm going to connect it with as smooth a continuous curve as I can. Okay. So it looks good. It's got that eyebrow kind of shape that I expect with this, with the square root. but I still need to find my domain and my range. Okay, so domain, what is the boundary to the left? What is the furthest left this graph goes? Well, since I don't have any negative values that work in this dot here, this is the furthest left it will ever go, and that lines up with 5, okay? So I know that my left boundary is a 5, but my right boundary over here is an arrow, so I know that that's going to continue on and on and on to infinity. And now as far as my range is my up and down. Well, I know that it's never going to get any lower than that big point that we started with, so that means it's never going to go any lower than -4 on that y, but it could continue to drift higher and higher forever and ever. So those are my range and domain. And you notice that these are different. You're going to have some boundaries when you're dealing with the square root, but not necessarily, you won't have those boundaries when you're dealing with a cube root. Okay, just 2 more left. Let's look at this. So describe the transformation of f of x equals the 4th root of 5. Oh, sorry about that. F of x equals the 4th root of x plus 5, represented by g of x equals negative 4th root of x minus 5. So that, it sounds a little bit confusing, but what we're really going to do is, what it's asking us is, this is our first, and this is the second. And how did we get from here to here? So it wants us to describe that transformation. Okay? So when we look at that, well, the first thing I notice is that this particular graph started up 5 from the origin. And this particular graph starts down 5 from the origin. And then it's also different because it has been flipped. It's a reflection. Well, that's all it's asking us to do, is to describe what happened there. So I'm just going to go ahead and say that from my original, which is f of x, to that other one, which is g of x, where it wants us to end up, there is a reflection, and it shifted down. But how far did it shift down? Well, it started 5 above 0 and it ended 5 below. So if I put those together, if I think 5 and then I subtract that -5, that's the same thing as saying 5 plus 5 equals 10. So that means it actually went down 10 units. So I described it. My whole answer is that it's a reflection and it shifts down. You could even say shifts down 10 units. And then finally it's asking us to write a rule. Okay, and that sounds like it might be a little intimidating, but really it's not. It's just asking us to represent that, to write that down, where we shrink by a factor of 5/6 and we translate 10 units to the left, and that we're starting with f of x is the cube root of x. So it's saying that if we start with f of x is the cube root of x, how do we get this other function, g of x, that made all of that stuff happen to it? So I'm going to start by writing my g of x, and I'm going to write my parent function in there because I know that's what I'm dealing with, right? I've got my x there. And now I just have to make it shrink by a factor of 5/6. Well, we've dealt with things that go out front, we've dealt with things that go inside, and we've dealt with things that go out the back. And I know that my shrink, if I'm going to shrink something, that's that number that goes out in front. So I'm going to go ahead and write that out there. Check, did that. Called it G. We shrank it by a factor. Now we still have to take it 10 units to the left. Well, so that knows we're going to be moving it by 10. And we have to have it inside this radical with it because that's where our left and rights are indicated. And if it's going to the left, that's going to be a plus. So there you go. We wrote the rule, told you how to do that, how to get your g of x. And we checked off all the boxes of all the things that we need to do.